Okay. Hello, everybody. My name is Ricardo Gonçalves, and welcome to the Rogue One, a Wi-Fi story. So, this talk is going to be about a project that I developed during my master thesis. At the beginning, it was to detect rogue access points, but then it expanded to a way to detect also Wi-Fi attacks. So, basically, what we will look over this talk, it's contextualize the background that is needed to understand the tool that was developed. And then we'll look to rogue access points, what they are, and Wi-Fi attacks that are sometimes needed and used together with the rogue access points. And the last part of this talk, we will see the tool in action. Actually, I record some demos. I don't trust doing some live Wi-Fi attacks here. So we'll also see a guide through over the detection process of this tool. So the thing that drove me to embrace this project and to develop this tool was basically the high expansion and our requirement for always being connected and everywhere. So in order to this be possible, we need to have these access points that will give us the internet that we want. And so these need to be always connected, and the easiness of perform some Wi-Fi attacks kind of drove me to try to create a tool that helps to detect these scenarios. It's not a protection tool, it's actually to detect. These are different things. So, sorry. So the thing here is, among all of these access points, how can we trust that we are connecting to a trusted source? And if you have, for example, a small company, how you can, in a cost-effective way, try to guarantee the wireless security. And yeah, basically it was all this kind of paranoia that made me create this detection tool. So in order to start and understand the heuristics used by this tool and how it is done, the process of detection, we need to understand a few concepts. So basically, when we talk about wireless, we are talking about 802.11, which are a set of rules on how to implement and use the wireless networks. Inside this 802.11, there's different operation modes. We have the ad hoc, where it's like peer-to-peer communication, and we have this infrastructure mode, which basically it's the one that we care about. It will be our environment, and it's where the mobile units communicate through the access points that serve as a bridge to other networks. And then we have the basic service set, which is our environment, which is the place where the things will happen. Basically, it's when an access point is connected to the wire network that will receive the actual internet that will be sent to the stations. And these wireless stations are laptops, our smartphones, and things like that are all together in this environment, which is the BSS. So we have the environment ready. So now we need to know all these entities, how these environments communicate between each other. So they communicate by sending some frame packets. And these packets, we have three different types: the management ones, the control, and the data. And the most important and the ones that we will use in order to create detections are the management frames that are used for management and admission controls. And they will allow some devices to initiate and maintain communications. They will send information like all of these subtypes of frames, which is like the associations, reassociation requests, the probe, the beacons, and other important subtypes that are going to take place between all this communication between these entities. And for us, we need to go deeper into the probe and the beacon frames. So, the beacon frames. We have the access points, we have the clients, and they need to talk between each other in order to understand them. So the first thing comes from the beacon frame that needs to announce itself and say, hey, I'm here, and I have all these capabilities. And these capabilities will be something like the name of the access point, which is the service set identifier, will be the basic service set identifier that is like the MAC address of the access point, which is unique and identifies that access point, and all the other subframe types, like for example the timestamp, that will be used to synchronize all the stations that are connected in that environment, the basic service set. So these beacon frames work in announces the access points, and you as a client will listen to that beacon frame. So you will do the things in the passive mode. But if you want to be more efficient, you can probe for that information. So there's where the probe request, the probe frames will come into place. So probe request is basically asking for the access point, information. You do this probe request, and then you will receive the response that will contain the other information that we saw previously in the beacon frame, like the name, the MAC address, and stuff like that. So having all this information together, we can now see the process of authentication to an open access point. So you will have the first case where the authenticator, which is the access point, will announce itself by sending the beacon frame. And then you can have, in some places, you asking for that information. So basically sending the probe request, and then you will have the information back, the probe response, and then will take place the authentication request, the response, and finally the association requests. This is a representation for an open authentication. If you will have an encrypted authentication, the next step would be a four-way handshake. So now we came to a point where we know what is an access point. We know what the clients, the supplicants are. So basically your mobile phone, your laptop, all these entities. And then comes to the point of what is a rogue access point. So basically a rogue access point is a non-authorized or a false access point which is created with malicious intentions. And sometimes it's used to support some Wi-Fi attacks. And these rogue access points, the most known one, it's the evil twin type, but there's different other types. So for example, the unauthorized access point is very much the case where, for example, a naive user or an attacker deploy an actual physical access point into a wired network. It will be there, it will be an unauthorized access point, and it is a rogue one. So the next one is the improperly configured. Inside this type, we can have, for example, access points that are configured with weak encryptions, like for example the web, and they are vulnerable to some attacks, and then they are again also a type of rogue access point, in this case improperly configured ones. The compromised is the case that affects pre-shared key WPA networks, which in this case it happens when your pre-shared key is disclosed somehow. So when an attacker knows about this pre-shared key, it means that your access point is compromised, and it is a type of rogue access point. So the last one, the evil twin, which is the most mainstream one, it's like a clone of the exact benign access point. So in this case, an attacker will pretty much clone all the identifiers that we saw in the beacon frame, and it will create an exact clone, which is the evil twin. This one can exist in two types: coexistence, where it pretty much exists side by side the authorized one, and the replacement, where pretty much you will deauth you will close the connections to the authorized one and only exist your access point. So these are the types of rogue access points. So what you can do if you create an access point. So basically you can perform man-in-the-middle attacks, and to this you can say to me, yeah, I use a VPN, I'm safe. Okay, that's fine, that's the way to go. But there are other people that don't use VPNs, and there's also the problem that if a rogue access point is deployed in your network, they can reach other nodes in the network, and they can target them and perform another type of attacks, like for example data exfiltration, or maybe flood the network with some random data. So at the next point, we have these Wi-Fi attacks. These Wi-Fi attacks, for example, the rogue access point with stronger signal, it's used in case, like I said, for example, the evil twin, where, for example, you have the real access point and the rogue access point. And in this case, by default, the 802.11 networks, they will give you the connection to the access point that has a strong signal. So if you have to choose between these two access points, you will pick the one with the strong signal. But by default, if you are connected to a rogue access point, you will not be disconnected because you have a stable connection, so you will not switch immediately to the strong signal. So what happens here, basically the attackers use the second point, which is the deauthentication attacks. They will send some specifically frames that send this deauthentication information and will make you disconnect from the real access point. And since you are now in this condition of choosing the access point, you will switch to the one with the stronger signal and you will be inside the rogue one. So the next one, the next Wi-Fi attack is the karma attacks. So before I explain the karma attacks, I just want to give you a little context that these are not all of the Wi-Fi attacks that are available, are the ones that are in the scope of the detection of this tool. So yeah, you might know about other types of Wi-Fi attacks, like for example the crack and attacks to web networks, but they are not mentioned here because they are not in the scope of the detection of this tool. So keeping on with the karma attacks, so it is the case where it targets devices that actively probe for networks. So my device, for example, can start saying if there's around the network, for example, headroom. And it will also again ask if the network, the Wi-Fi event, for example, is around. And what the karma attack is basically responding, yes, I am headroom. Yes, I am Wi-Fi event. Yes, I'm other network. So basically, the same device will say that it is different type of devices. And this will target these supplicant devices, these clients that actively probe for rogue, for access points. So then the fourth one, the rogue access point with radius server, is pretty much similar to the one describes, but targets 802.11 enterprise networks. And to these, you can use tools, for example, like host APD WPE that will create a fake radius server, and you can pretty much explore the victims targeting these networks. And the last one is the PMKID attack, which is a recent Wi-Fi attack, was discovered, I think, August this year. And it targets, again, WPA2 pre-shared key networks, and it will allow the attackers to obtain the pre-shared key that are using that in that particular SSID. So it kind of gives you the same as the old Wi-Fi attacks, where you would target a network, deauthenticate a client, and try to crack the handshake. But in this case, the thing is that you don't need to actually have clients inside that network. You will just interact with the access point. So the attackers will target the reassociation process in order to obtain a master key ID, which is pretty much this PM key ID. And this is derived from the access point MAC address, the client MAC address, the PM key, and the PM key name. So these ones are easy known by an attacker. The one that it just needs and wants to know is the PM key, which is derived from the pre-shared key. And if you do a dictionary attack, you could basically crack the password of that access point. The thing here is that maybe some of you already tried and you couldn't break your neighbor's network, is that it only affects, or mostly affects, wireless vendors that using roaming technologies. So usually our home routers don't have this capability, so yeah, we kind of safe from this one. So we now know about the Wi-Fi attacks that are in the scope of this tool. We know about the types of rogue access points. We came to the point where we'll look at the tool that was developed. So basically this tool detects different types of rogue access points and some Wi-Fi attacks. It is a modular framework. It was divided in different modules in order to make it easy to extend it for different things. It is a stationary one, so basically, yeah, it could be improved, but if I started this tool here, it will just capture all what's going around in this room. So it is limited to its scope. And it can be used in Linux systems and is configurable for different users. If you are a home consumer, you will just configure with what you know about your network. If you are a sys administrator and you have a different network, you can put some different specifications. So basically we have this main tool, which is the rogue access point detector, and it will load a profile or not. It is up to you. If you place this profile, basically you are saying information about your network. And these informations are the name of your network, your MAC address, the amount of access points that you have, the channel where they are configured, the type of the encryption type that you are using, the signal strength of your access point. All this information will be stored in a profile that then will be used for a part of the detection process. Apart from this profile, which is an optional one, we'll have underneath a profile for free Wi-Fi networks. It actually has just some free Wi-Fis from the Portuguese ISPs, the NOS networks and MEO networks, and it will use an heuristic that I will explain further on in order to give you some authenticity about these free Wi-Fis. So then, once the profile is loaded, we'll go to the modules where we have the scanners and detectors, which are passive ones, and we'll have the actuators, which will do active approaches. So basically, the scanners do the scanning process. It does this scanning process with the IW list from Linux systems, or it can use the SCAPI, this framework, and this will basically scan what's going around in the air. And doing this, you will face a problem, which is you need to filter the access point, because if you just keep listening, you will have a lot of the same access point will have a lot of times. So you need to do some threshold in order to just keep once the access point and don't have a flood of that. So basically the scanners will give you all the information about what's going around in the access point. And then we'll place the detection process. Detections that the tool have, the passive ones, are the authorized list techniques, which will depend from the profile that was configured. If you don't configure a profile, it will use a no-knowledge network, no-knowledge detection process that will basically use what is known in the air and try to do some no-knowledge heuristics over these access points that are announced. So even if you don't configure the authorized list, you can still have some results. Apart from that, we have a blacklist technique, which will most of these Wi-Fi attacks happen for some default brands, like the Pineapple APs, Alpha interfaces, and this is not immediately saying that this is a rogue access point, but it will trigger something and say, oh, something is going wrong, and we have found an access point that has a brand from Alpha card. That's not normal, so you better take a look. So the next one is the validate free Wi-Fi authenticity, like I said, and I'm going to explain later. The deauthentication attacks detection, karma attacks detection, it works both in passive or active mode, and the PM key ID attack detection. Next one, we have the actuators, which will support the detections that are described in the previous section. So these actuators will pretty much do the active process. They will associate to the access point and will retrieve these amounts of information, like the IP, the ISP information. Will calculate a trace route, for example, for a node in the network, or for a website that you know the amount of hops that you need to do to reach it. And we'll also calculate the access point fingerprint. Actually, this uses the Nmap framework, and we'll do a scan over that node, and we'll give you information about that access point. The last one is the countermeasure mechanism, where you can basically deauthenticate a rogue access points. So now we'll look thoroughly to the heuristics to detect. The first one, the authorized list detection, it's composed of 4 detection mechanisms. The whitelist one, it's the most easy one and known by everybody. We pretty much see if the announced SSID, the announced name of the network, if we have 2 announced networks with the same name, and we have the different BSSID, which is unique per network, we will alert the user about that something is wrong. Of course, that this is failable, but that's why we have on top of that another heuristics. The encryption heuristic pretty much will look if the encryption scheme used by the access point is different for the one that it's authorized. So if it is different, it will alert the user. We also have the multi-channel detection, which will see if this same access point is announced in a different channel, which is also gives you an alarmistic about this thing. And the last one is the received signal strength indication heuristic, which will pretty much will see if your access point, the access point announced, is inside of a baseline of the RSSI. So in your profile, you configure this baseline because you know about your network and you know the signal strength that you have. Of course, that this is the air spectrum and we have interference. That's why you have this baseline there that you need to fine-tune correctly. And if you do this, it will not alert you, but will prompt you if you want to connect to that access point. So if it's your authorized access point, you will successfully authenticate and will do the heuristics that I explained in the actuators. And you will see that information and see if it really matches your access point. If it really matches, that's okay, you are good. Otherwise, something is wrong. Maybe an attacker knows your pre-shared key and create an access point similar to yours, and you are kind of in trouble or not. So to this, I have a little video to show the process of detecting, of using the authorized list detection process. So I hope this can be seen with good quality. So basically, in order to start the detection with authorized lists, we need to load this profile with the flag +p. And this profile, it's basically what I said. You will put the information about your access points. And so we just start the tool with this, and we will start looking what's going on around. Here it's just showing our access point, lab network, because we are using a profile. If we are not using a profile, we will see a bunch of access points, where I'll show you later on. And now, in this second window, I will create an access point that will represent the first case, where it is the one that it is a BSS ID that is not authorized. So I create this access point using the tool. It has a method which is the /h flag, which is the hive mode, where pretty much you can configure a profile called rogue access point profile, where you will pretty much set the configs for your rogue access point. This is mainly used for testing purpose, nothing else. Trust me. So I started the rogue access point, and you can see immediately that it's not readable enough, but I can tell you that it says evil twin unauthorized BSS ID. And on top of that, you can also see that there's that information about recently created access point. So, and this is because of this TSF function, which is the time synchronization function that, like I said, it's the way that inside the environment, the BSS, they will synchronize all the entities inside that BSSI. So basically, since this access point is created now by an attacker, of course that you can use tools that can have some specific time for the TSF, but by default, I am using the Scapy framework to create the rogue access points. It will start by 0. And by 0, it's a recent access point. I don't have any other access points in my lab environment, so it will be strange. So the next one, we'll go to the profile where we configure the rogue access point, and we'll change it to target the next case, which is the encryption scheme. So we change it to the open access point, and we will see once we start the access point that will trigger us the alert. In this case, these are two alerts. The first one saying about the multi-channel thing, because apart from you are deploying a rogue access point that is similar to the one that you have in your network, you are deploying in an incorrect channel, so it says that it is a multi-channel access point, and also give you the information that the encryption is different. So this one is open and yours is a WPA2. So, and again, it's recently created access point, so this gives you some information that something is going wrong. So the next one will be the received signal strength indication heuristic. So in this case, you will have, for example, a scenario where the attacker will increase the signal of the rogue access point. And in this case, once you start the tool, you will be prompted about, if you want to authenticate to that access point. You can see here that, yeah, actually you can't see, but I'm telling you that it is saying that strange received signal strength indicator, do you want to associate? If you do okay, it will ask you for the information about that network, the interface that you want to use to authenticate, the password of the access point, and yeah, it will try to associate. After this association process, if it works correctly, it will perform the heuristics that I said. Internal IP information, external ISP validation, the trace route actually is calculating it, and then it will do the fingerprint with Nmap. So with this, since we were connecting to the authorized access point, these informations are the correct ones. But if we were in the case where we have an access point deployed, for example, without encryption, you will have different results. Or if it is a one that it's similar to mine, because my pre-shared key was leaked, maybe it would be somehow difficult, or maybe the attack will not immediately think about it, and something here will not be right. So about these detections, we are clear. So the next one is the validate free Wi-Fi authenticity. So in this case, we notice the pattern that happens in some networks. Basically, the thing is that in the NOS and MEO free Wi-Fis, the announced free Wi-Fi follows a specific pattern in the creation of the MAC address. So because this network is announced from the same access point where you actually have your authorized, your home network. And since it's from the same access point, the MAC address is derived from it. And what happens in the NOS free Wi-Fi is that the last byte from the BSSID will increment 1 unit. And if this happens, we will give you some heuristic that probably this NOS Wi-Fi, it's an authorized one. This is just probably because an attacker can think like we did and deploy this authorized network and create the right conditions to trick my tool. So this is okay. But this is a different step and an extra layer that can give you some confidence that this access point is actually trusted or not. So the same happened for MEO free Wi-Fi. The first byte is incremented 2 units and the last byte 1 unit. This also happens for example, it is also configured in the tool for Wi-Fi Advantage and University of Porto access points, because these BSSIDs are derived from the headroom 1 and follow a similar pattern. So we use that also to identify if someone is playing around. So in the demo to see this working, it's pretty much you just need to run the tool, and in this case you don't pass any profile. The thing that you pass is basically the interface and the scanning mode that you want. Here I'm using the IW list, and you will see that it will immediately say that are some probably valid free Wi-Fis, and if we look at the pattern, they are the ones that I described before. So yeah, it is trying to do the same from this mail. This one failed, but you can see over there that it actually found some probably valid free Wi-Fi. Then I ran the tool with Scapy framework just to show that it also works with Scapy. But the thing here, it is a little slower with Scapy because you need to do the actually channel hopping. You need to code this channel hopping, and because of this, the tool becomes a little slower in this situation. But you can see that it already detected a probably free Wi-Fi network. So as for the validate free Wi-Fi's, that's it. We could do other heuristics, but it's kind of a fair, accurate to detect rogue access point in such conditions. So the karma attacks detections can be done in different modes, the active one or passive. By default, the tool runs in passive mode, where we just listen for some probe responses that will fall into the condition that these probe responses will say that it is different SSIDs from the same access point. So we spot a karma attack. If you want to be more active and you have some speed results, you will activate the active mode, which will probe from different SSIDs, and since this attack is running, it will just be spotted because it will answer to all these requests. So to detect this, basically we just again run the tool in the normal mode. You don't pass any more flags except from the interface and the scanning process. And then in this second window, I will perform the karma attacks using the Airbase NG tool. And once I start it, we will see that some karma rogue access points will happen. We have the first one, which is the default access point, which is created by the Airbase tool. And then you will see in a while, yeah, that it detected the karma attacks for this node 0157 network. So yeah, basically we detect the karma attacks. Okay, so the next one, and I think yeah the last one for the videos, is the PMKID detection, which in this case we will need to run the tool in a different way, which is we need to pass a different interface. In this case, it's the high M interface, which will need to put your interface in a monitor mode, and then we'll pass the flag the Wi-Fi the attacks detection. Once you start it, we will start looking for what's going on in the air. And in this window, I started the PMKID attack using the HCX dump tool, which basically will try to do this PMKID. And how it works, like I said, it will use this will target the reassociation process. And what it does, it will try to do a bunch of authentication requests and association requests in order to see if it can leverage that PMKID from the access point. And so we gather all these authentication requests from a specific access point, targeting a specific access point, and you will alert the user that something is going wrong and it's probably a PMKID attack. So as long as we run the tool, we will see all these packets going around, which is not normal, and they are target all the same network, or if they were done in broadcast, they will target different networks. And we also see here these deauthentication packets, because the tool also identifies deauthentication attacks, but these ones are kind of legitimate because it's reason 15 code, which is pretty much it's the four-way handshake timeout, because once you are trying to do these associations requests, you will interact with the access point and you will fail doing it, and the access point will send you the information about the authentication packet. The four-way handshake went wrong. So in the next step, we configured this, used AirReplay to send some deauthentication attack to show that it also detects deauthentication attacks. Like we already see, it detects the deauthentication packets. But yeah, just to be sure, I changed the channel of the interface to be in the same one of the target access point, and we can see that it's flooding many deauthentication packets, and we can see that we rightly identified the deauthentication attack. So basically these are the detections of the tool. They are covered some of the detections process, and in the next slides I'll show you a small case study that was done in the company where I work, and it's pretty much we were doing a Wi-Fi assessment, and the auditor representing the attacker tried to to validate the Wi-Fi security of our networks. And so basically, he deployed a bunch of Wi-Fi attacks that were unknown to us, and we were running the tool in the background just to see how it behaves, and we can see that we have three different types of detections. These ones here are shortest to represent the ones that are not identified in the previous demo. But the first one will identify rogue access point with same SSID and different BSSID. The second one will identify rogue access points with actually everything exactly like the ones from our company, but failing in a different RSSI. And the last one, it's pretty much identifying karma attacks, and the one that I didn't show, the blacklist heuristics. So in the first case, the auditor was just setting up the tool and didn't pay much attention, and he just deployed the rogue access point, not caring about BSSID. So this BSSID is not one of our authorized ones, and we will immediately spot that a rogue access point was going around. So the next one, challenge accepted from the attacker, and he really go deep and configured an exact access point of our own. And in this case, what failed here was that it configured it with a much higher RSSI, with a much higher signal, and it showed something strange to us. We tried to authenticate to that, and since it's an enterprise network, the authentication process failed because the attacker didn't. Our process of authenticating to that network was not the one of the attacker, so it failed the association process. And basically, in this kind of attacks, the attacker just wants to steal your credentials, so it will just target the first phase of the authentication and will not actually authenticate you to the radius server. So it failed, so it spotted that there's a rogue access point around. So the last one, the rogue access points from the Pineapple AP tool and the Karma attacks, was spotted inside the blacklist heuristic because Pineapple, oh, so cool. The Pineapple access points are blacklisted by our tool, and Karma attacks we already saw. The auditor started a bunch of Karma attacks, and we saw that something was going wrong. And we successfully identified this rogue access point, these Wi-Fi attacks. A thing here is that apart from this, the tool also has a log mechanism where, for example, you could integrate it with a CM system and you could receive these alerts in real time and monitor them in your infrastructure. But as the way it is configured, we just run it in the terminal, and that's great for us. But since it has this log system, you can actually connect it to a CM. So to conclude, so we saw a tool that it's an open source modular framework. Actually, if you are interested, you can look it at GitHub, and then it pretty much identifies different types of rogue access points, like evil twins, unauthorized, improperly configured, the ones that was described previously, and also detects some Wi-Fi attacks like the Karma, the authentications, PMKID, and I added here this limited crack detection because the way the crack attack starts, basically one attack vector is to deploy an access point in a different channel. So we have that multi-channel detection that I don't say that it is specifically a Karma attack, but it's something strange that you should look on. So basically that's it. If you have any question, please go around, and thank you all for your time. Any questions?
Yeah. Hi. Have you thought about implementing like an auto-learning feature for profile generation and stuff like that?
Yeah, that would be great, yeah. For example, I think in a scenario for the free Wi-Fi's, that could be interesting because it's really hard to maintain all these profiles for free Wi-Fi's. So we have a couple of detections, but it will be interesting if you have this auto-learning feature. But yeah, it's something to think about in the future. Yeah, also expand the tool from a stationary point to a way where it's deployed in different nodes will be great. Yeah.
Any more questions?
That's it.
All right. Thank you, Ricardo.
Okay. Thank you.